Review of basic concepts. R5. Rational expressions. An expression that consists of a polynomial divided by a non-zero polynomial is called a rational expression. The following are example of rational expressions. So we learn about what is a rational numbers, and also we learn about the polynomials. So this is the example for rational expressions like 2 over 3, or even that's a variable over a variable, or that is a monomial over a binomial, trinomial over the binomial. All these are the examples of rational expressions. First, we need to know how to find the domain of a rational expressions. For example, I have an x plus 6 over x plus 2. Okay, this is the rational expressions, and we want to find what is the domain. Domain means what possible values of x can be for these rational expressions. So think about it. For the numerator, x can be anything. It doesn't matter as a positive number or negative number here. However, for the denominator, remember denominator cannot be equal to 0. Okay, we can't have the 0 on the denominator. So when we want to find the domain, we try to set x plus 2 not equal to 0. Okay, this guy cannot be equal to 0. And we're gonna figure out what is your x equal to. So x cannot be equal to negative 2. So think about it. When x equal to negative 2 on the top, that will be 4. 4 over 0. That's undefined. So x cannot be equal to negative 2. So we're gonna say the domain will be the set of all real number x, but not equal to negative 2. Okay, remember the set builder notation? The set of all x such that x cannot be equal to negative 2. So this is the idea of the domain of a rational expressions. Okay, example 1. Finding the domain of the rational expressions. Same idea. Numerator doesn't really matter. For the denominator, it cannot be equal to 0. So we're gonna set x plus 3 times x minus 1 cannot be equal to 0. Okay, and then we solve for the x. So either x plus 3 not equal to 0 or x minus 1 cannot be equal to 0. So we figure out x cannot be equal to negative 3, x cannot be equal to 1. So I write it in the set builder notation. The sets of all x such that x cannot be equal to negative 3 or 1. So this is the domain. Okay, example 2. For this kind of rational expressions, first, we try to write it in the lowest terms. Means like try to factor out to see if you could simplify something. So look at the top here. What is the common factor? That would be 6x, right? So factor out the 6x to see what you have in here. And then this one, how can you factor the binomial? Remember how to factor the two terms? Using the formula, right? So that would be 2x plus 5 times 2x minus 5. On the top, I just factor out the 6x here. So you can see this is a multiplication, okay? 6x times 2x minus 5. And then 2x plus 5 times 2x minus 5. So we could simplify these two guys. We're left with 6x over 2x plus 5. And then we want to find the domain. So we're going to set the denominator cannot be equal to 0. Solve for your x. Minus 5 for both sides, divided by 2 for both sides. So x cannot be equal to negative 5 over 2. So write it in the set builder notation. X can be anything, just cannot be equal to negative 5 over 2. Okay, right? Try this one. This one I just need you guys write in the lowest terms. So you try to factor in the trinomial and factor in the binomials. So you guys should be able to do it, right? Factoring on the top, that's a perfect square. This one, find out the common factor, which is going to be 2x. Okay, x minus 4 squared, and this is a 4 minus x. Okay, we can't just simplify it. We want to factor out the negative here. Now, I could cancel out one of the x minus 4. So that will be your final answer. If we want to find the domain, we would say negative 2x cannot be equal to 0. So means x can be all real values, x cannot be equal to 0. Okay, multiplication and division. So when you multiply these two fractions, you could just a times c over b times d. If you could simplify before you multiply. Okay? If that's a division, you're gonna make the division change to multiplication and then flip the second fraction. So c over d, flip it, become d over c. Simplify before you multiply. Okay? So same idea, this is gonna be multiplication. Before I multiply it, I would simplify it first. So 6 and the 9, right? I could divide it by 3 here. Okay, and then the 7 here, 7 divided by 7 divided by 7. So that will be 4 here. Okay, and then the x6 divided by x squared. So take it out. You're left with the 4. So final answer will be 2 times 4, which is going to be x to the power 4 divided by 3. Okay, right? Okay, this one. When you have the trinomial and the binomial here, first things you need to do, factoring. Okay, try to do it by yourself. Factor out this guy, factor out this guy. Okay, try your work. Now you could simplify. I could simplify x plus 2, simplify 2x minus 1. So I left with this guy. Okay, see, this is a division. You're gonna change to multiplication and then flip the second fraction. And also you want to factor out one by one. Try. Okay, I just changed the multiplication, flip the second fraction first. and then do the factoring. Okay, simplify one by one, you should get x over 3. Okay, right? X minus 3 cancel out. 5x minus 1 cancel out. X plus 4 cancel out. 2x cancel out. So you have an x over 3 only. Okay, last one. This is a polynomial. This is a 4 terms. Remember the factor by grouping? And this one, you may need to use the formula. A to the power of third minus b to the power of third. Okay. Now simplify it one by one. Okay, you cross out the x plus 1 also. So you left with x minus 2 over x squared plus x plus 1. This one is not factorable. Addition and subtraction. So you want to find the LCD and then make the, when they have the common denominator, then you could add it up or subtract it. Okay, let's try to do it together. Adding or subtracting the rational expressions. So look at these two guys, the denominator. Find out the LCD, okay, the least common denominator. So for the 10x to the power 4th, I could revise it to this guy, 2 times 5 times x to the power 4th. 15, I could put like 3 times 5, x squared. Okay, we're gonna take the greatest one. So we have a 2 times 3 times 1, 5 times x to the power of 4th. That will be the LCD, 30x to the power of 4th. Okay, now think about it. What do you need to multiply to get 30x to the power of 4th? You're gonna times 3, right? So when you times 3 on the numerator, you're gonna times 3 to the denominator to make it like the LCD. So this guy, 15x squared, you need to times 2x squared. Okay, right? So when they have the same denominator, you could add up the numerator. But since this is not the 9 terms, you can't combine it. So this is gonna be your final answer. Okay, this one is really special. Like the denominator is similar, m minus 5, and that one would be 5 minus m. Okay, so I could rewrite this guy. I could keep the m minus 5 here. And this one, I would factor out the negative 1. Okay, factor out the negative 1 and become m minus 5. You could double check. Negative 1 times m would be negative m. Negative 1 times negative 5, that would be positive 5. Okay, so the LCD will be m minus 5, and then the negative 1, I just multiply it here. Combine the 9 terms. Hey, make sure you guys understand this technique, okay? They are like to each other, but this is not exactly the same thing because the subtraction, the order doesn't matter. Okay, m minus 5 is different from 5 minus m. So the only way you can do factor out the negative 1. Okay, make it like the same things. Okay, this one. Find out the LCD. Think about it. What is the LCD? So the LCD will be x minus 3, x plus 5, x minus 5. Now, the first guy here, you want to multiply x minus 5 to the numerator and the denominator. And this guy, you need to multiply x minus 3 here, x minus 3 here. Once they have the same denominator, you could combine the 9 terms. So first, you want to distribute one by one. Distribute it. And then combine the 9 terms. So 4x minus 6x, that will be negative 2x minus 2. Okay, you can't simplify it. So that will be your final answer. Okay, simplifying compressed fractions. Compressed fractions means like on the numerator, I do have the rational expression. On the denominator, I also have the rational expressions. First, find the LCD. We're going to look at all the denominator. The denominator of 3, that's a 1. Denominator of this guy will be x squared. Denominator of 6 will be 1. Denominator of this guy will be x squared. So you know the LCD will be x squared. After you find out the LCD, you're gonna multiply the LCD for the numerator and the denominator. And then you're gonna distribute it like one by one. After you multiply the LCD, you should be able to cancel out this guy. Okay, 3x squared plus cancel out, only plus 4. 6x squared minus 1 here. Can you simplify it? No, right? That's it. Okay, next one. Again, find out the LCD. Make sure you look at like every single terms. So x plus 1, x minus 1, x, and x plus 1. So this is the 4 terms here. What is the LCD? LCD will be x times x plus 1 times x minus 1. Then on the numerator, you're going to multiply the LCD. On the denominator, you're going to multiply the LCD. So distribute one by one. So here x plus 1 you cancel out. So you're left with x times x minus 1. And then second terms, you cancel out x minus 1. You should got this. Same idea for the denominator. And remember, every time when you multiply the LCD, it won't be the compressed fraction anymore. Okay? Now, distribute it like one by one. Combine the 9 terms. So that will be your final answer. That's it.